adding and subtracting polynomials, that's our lesson for today. We have been talking about integers and the rules that goes with, not integers, exponents and the rules that go with them. Now we're going to talk about things that have exponents and adding and subtracting them. We've done this before, only when we did it before we called it adding like terms, but it's the same thing. Definitions really quick. Monomial is the first thing. That's how you say this word, is monomial, not monomial like the Dr. Pepper commercial, but monomial. Here is your definition for a monomial. It is a number, a variable, or a product of numbers and variables with whole number exponents. We haven't talked about exponents that aren't whole numbers, but that is part of the definition, so we had to make sure that it was in there. So examples of monomials are, a number like the number 2, a variable like the letter x, or a product of the two like 2x, or we can add exponents to it. We can go 2x to the third. All of those are monomials. Number, variable, or product of numbers and variables. So you've seen all these before. Now they have a fancy new name. We call them monomials. Binomials is just a fancy kind of monomial. It's not really. It's a fancy kind of polynomial. And all a binomial is, my pen does not like me, the sum or difference of two, hence the bi-monomials. So it's two monomials that are either being added or subtracted. For example, 3x plus 4 is a binomial. 6x plus 5y is also a monomial, but it could also be a subtraction, so you could also have like 2x minus 13. Those are all binomials. It's two monomials added or subtracted. So trinomial should be pretty easy. Trinomial is like a binomial, except instead of two monomials together, it's 3 of them. So trinomials is the sum or difference of 3 monomials. For example, 2x squared plus 3x minus 1. That is a trinomial because you have 3 different monomials separated with plus and minus signs. So that's what we call a trinomial. A polynomial is the word that we give to group all of these. It's sort of like quadrilateral is all 4-sided figures, and under quadrilateral you can have squares, rectangles, rhombus, trapezoid. But so polynomial is like the big word that covers them all. Definition of a polynomial is the sum or difference. I hope at some point my pen stops being silly. The sum or difference of 2 or more monomials. So a binomial is a fancy kind of polynomial. A trinomial is a fancy kind of polynomial. And anything bigger than that is also a polynomial. But polynomial is like the big word that covers all of it. And you have to remember, a monomial is just the single little term. It is the number, the variable, or the product of the two. So there are your definitions. Now let's practice this. So based on those definitions back here that we just did on this page, the monomial, binomial, trinomial, polynomial, we're going to circle the true statements. So the first statement we have is that a monomial is a polynomial. This is not true because a monomial doesn't have a sum or difference in it. It is either a number or a variable, or it's a product, but there's no sum or difference. So that one's not true. The next one, 4a to the third minus 7 is a trinomial. Well, it can't be a trinomial because it does not have 3 terms. This only has 2. 4a to the third is one monomial, 7 is another. So this is not a trinomial. This one is actually a binomial, so that one's not true. The next statement, a binomial is a trinomial. Well, to be a binomial, you have to have 2 terms. To be a trinomial, you have to have 3. So it's kind of like saying a square is a triangle. No, because you don't have enough. So this is not true either, because a binomial has 2 terms, a trinomial has 3. And then the last one, a polynomial has 2 or more terms. This right here is the only one that is true, because that was the definition of polynomial. It has 2 or more monomials. So that's the only true statement in that group. The polynomial has 2 or more terms. Now, algebra tiles. There should be a plus sign here, just so that we can get used to what they look like, because you're going to start seeing pictures of these and you don't want to be confused when you see them. These big squares represent x and negative x. I just lied to you. They're squares, so they're x and negative x squared. The long rectangles make your x and your negative x. And then these littler squares that you see show up are your units. They're your 1 and they're your negative 1. So we want to add up these 2 sets of algebra tiles and come up with a simplified version. And so these are negative x squareds, and this is a positive x squared. Well, if I am adding these up, 1 positive x squared cancels out 1 negative x squared, so these cross each other off, leaving me with a negative x squared. And then I have all these x's. I have 1, 2, 3, 4, 5 x's, and then I have 2 negative x's. Well, each one of these negative x's will cross off one of my positive x's, as they make a 0 pair. It's just like the 2 color counters. And so now I have 1, 2, 3 x's left. And since I'm adding, now I have plus 3x. And then I have these 2 little ones here that are both negative 1. So I have plus 2 negative 1s, which is the same thing as negative 2. So I have minus 2. So when I combine all this together and take out 0 pairs and get everything down to its, the simplest form it can be, I end up with 1 negative x squared plus 3x minus 2. This is what that equals if I add them together. And this is what you're going to be doing today. We're just not going to be doing it with the pictures. But so this way, if you see a picture or you see the algebra tiles show up somewhere, they don't throw you for a loop, because you've at least seen what they look like. So let's add and subtract a couple of polynomials. This is nothing more than like terms. And if you remember when we talked about like terms, they have to be completely the same in every single way. The variables have to be the same. The exponents have to be the same. So an a to the third goes with another a to the third, and I can add them together. So 5a to the third plus 7a to the third, you just add your coefficients, which is 12, because 5 plus 7 is 12, and that's still a to the third because I'm adding up how many a to the thirds I have. You are not going to add exponents. This is not a multiplication problem. Do not get the 2 confused. You just add the coefficients, keep everything else the same. So I'm just totaling up how many I have. Now there are no more a squareds present over here for me to add with, but there is one here. So I've got plus 3a squared plus 12a squared, and I can put those 2 like terms together because they are the same. So 3 plus 12 is 15, so I have plus 15a squared. And then I can do my a's. I have minus 6a plus negative 10a, and when you add those 2 negatives, you end up with negative 16a. So I've just added the polynomials together, and I did that by combining like terms, which is not a new concept at all. So subtracting polynomials, this one's going to be a little different, because this negative sign, or this subtraction sign that is in between the 2 sets of polynomials, means I have to minus this, and minus this. So I think it is helpful to rewrite this problem by distributing the negative to everything in here. So I'm going to rewrite this. I have 6x squared plus 8xy minus 3y squared. That's the first polynomial that you had. Now I'm going to distribute this negative to all of these. So I have negative 2x squared. Negative times a positive is a negative 3xy. And this negative make a plus 2y squared. So all I did was distribute this negative to everything in here. This way, the subtraction has taken care of itself, and I can just take care of my like terms. So my first set of like terms, I have 6x squared minus 2x squared. Well, 6 minus 2 is 4, so that's 4x squared. Now I have my xy, so I have 8xy minus 3xy. And when you do 8 minus 3, that's 5. So I have plus 5xy. And then I have these y squareds. I have negative 3y squared plus 2y squared. And negative 3 plus 2 is negative 1, or negative y squared. So I've subtracted those two polynomials by distributing this negative to everything. So I changed all the signs of this and then just combined like terms. Couple more examples. We want a polynomial that expresses the measure of angle ABD. Well, angle ABD is this big one right here. So I have to add these two together to get the whole thing. So what I have is 8a squared minus 2a plus 5 plus 7a plus 4. Go ahead and keep the parentheses. That way you can see that you had two different polynomials that were being added. So like terms, 8a squared, there are no other a squared, so I'm just going to bring it down. There's nothing to put it with. I have negative 2a plus 7a, which is 5a, and then I have 5 plus 4, which is 9. So here is the polynomial that represents the measure of that great big angle all put together. I just added the two polynomials. So now we're going to fill in some missing statements. Just going to practice a couple of things. If these are my two polynomials and I want the sum, I just have to add these two together. So I have to do x squared minus 6 plus 3x squared minus 10x plus 2. Like I said, keep your parentheses so that you can see you had two different polynomials being added, and then add like terms. X squared plus 3x squared is 4x squared. And then this minus 10x doesn't have a buddy over here. So we're going to have to bring him along, minus 10x. And then we can do the last little step. I have negative 6 plus 2, which equals negative 4. So there is the sum of those two polynomials. I have added them up. The next little one, I have x plus x squared plus 6, and this is the sum of this and something that's missing. Well, if this plus this gave me that, then I have to subtract in order to figure out what is left. So I started with this. I have 3x squared plus 2x plus 1. That's the polynomial that I have. That was my sum. And from that, I have to subtract the polynomial that I started with. So I have x plus x squared plus 6. So we're going to distribute our negative like we did just a minute ago. So I have 3x squared plus 2x plus 1, and then distribute your negative, so you have negative x minus x squared minus 6. And now it's just like term time, so we're going to put them together. 3x squared minus x squared leaves you with 2x squared, so that's what went here. And then 2x minus x left me with a positive x, so I have plus x. And then my numbers, 1 minus 6 is negative 5, so that goes negative 5. And if you go back and double check, this plus this will give you this as a final answer, and you can go test. Now try this one on your own, and we'll talk about the answer for this last one in the table tomorrow when you come into class. But go ahead and try it and see if you can do it, and we'll talk about it when you come in. So one last example. It says to draw a picture and then solve. Tell you the length of a rectangle is represented by 2x plus 3 feet, and the width is represented by 3x plus 7. The perimeter is 35 feet. They want to know what the value of x is. Well, the first thing you need to do is draw yourself a rectangle, because that's what you need. And label it. One side is 2x plus 3. The other side is 3x plus 7. And I know that if I add all four sides up, it should equal 35. Well, so let's go ahead and add up all four sides. 3x and 3x is 6x, plus 2x is 8x, plus another 2x is 10x. And then add your numbers. 7 plus 3 is 10. Another 7 plus 3 is 10, so that is 20. And it has to equal a perimeter of 35. So finish from there, and find out what x equals. And we will talk about the rest of this tomorrow when you come to class.